Yeah, comes on everyone. Let's start off. So this was the last thing that we did. Hope everyone has gone through the rules. Let's see some questions on this. So just to brief it up again. So during addition or subtraction, what we do is we always make sure the number of decimals are same, the least number of decimals. Whereas for multiplication and division, you just multiply and make sure the least number of SF are there. Significant figures. So I'll give you some calculations. Give me the readings here. 3 point. Let's get them all. Others, do keep your cams on. Try. I'll give you 1 minute more, then I'll show you everything. You can check your answers. Let's see. First one, see. 3.2 into 1 is 3.2 centimeter square, but this guy is only 1 SF. So we need to round off this to 1 SF, so that is 3 centimeter square. This thing would be 6666000 centimeter square. But remember, this thing has only 1 SF. So this is 6.666 into 10 power 7 centimeter square. We need to round off this. So look at the second digit greater than 5. So this becomes 7 into 10 power 7. Isn't it? 6000 has only one SF. This thing is 0.74, 20. This thing has 3 SF. So if you take 20.0, 20 will have only one SF. You need 3 SF, so 20.0 or 2.00 into 10 power 1. This thing is 22, but remember this thing has only one SF. 2 into 10 power 1. This is a root 0.16, which is 0.4. But remember, this thing is 2 SF. That is the minimum. So I need to make this 0.40. The decimals, the zeros after decimal are counted. Clear with this?
So in the D part, that would be 2.2, right?
नहीं ना 1 SF ना 2.2 आएगा नहीं.
Oh, okay.
All clear with this? Clear with the rules. Check it out. It's a not tough, easy, but yeah, you should know your rules and stuff. Things can be weird sometimes. Next one. Next thing. Length of a rectangle. 4.32 centimeters. Breadth of rectangle is 2 centimeters. Find first thing area. Second, twice the length. Let's get them. Let's see. Yeah. The first one, area is length into breadth. That's 4.32 centimeter into 2 centimeters. That's 8.64 centimeter square. But remember, this thing has only one SF. So we round off this to 6 is, look at this digit greater than 5. So this will become 9 centimeters square. There is a second one. It looks the same. 2 into L is 2 into 8.4.32 centimeters. Now understand the difference. This is a number. It has infinite SF. This thing has 3. So that means the minimum SF is 3. It's not 1. So this would be 8.64. Getting the difference? Both the cases, it looks like you're multiplying by 2. In one case, you multiplied with a number. In one case, you multiplied with a measurement. I hope this was clear. There. So that is about the significant figures, addition, subtraction, multiplication, and stuff. Like I said, it's easy, but you should know the rules. It can be confusing. I'll be sending you a sheet on all these things today. So the units and dimensions, errors and all, not much, maybe 40, 50 questions. So I think if you do that, that much is sufficient. Next one. Errors. Turning the page. Any doubts on this, please ask. So what's an error? The difference between the actual value and the measurement. Now, there are two more words which we keep using. One is precision and accuracy. Precision says how close the measurements are. I'll tell you what it means. So precise doesn't mean you're right. Accuracy tells you how close the measurement is to the actual value. I think the better will be a picture would. You get this thing. So hitting the bullseye, right, is the precision, basic accuracy. Now, if you look at the first diagram here, the values are spread out. There is no accuracy, there is no precision. But look at the second one. You can say all are wrong, but all are pretty close to each other. So in this case, right, meaning the values, right, are pretty precise, but they're not accurate. Meaning this kind of thing, when will happen? For example, let's say you have a scale which you're using to do measurements, something like this, 0, 1, and all. But some of you have a habit of eating a scale, right? You take the scale, put it in the mouth, and keep nibbling it. So, and then sometimes what will happen? The scale gets messed up like this. So some of the divisions are missing. So the 0 is somewhere here. You're getting it? Now, if you use a scale like this to measure, what will happen? Won't all the values get messed up by this factor? You're getting values properly pretty close to each other, but all the values got messed up. So something like this is happening here. So there was an error in an instrument or something. There's a problem with the instrument, which is giving good values, but all got error by the same amount. This thing is high accuracy or pretty close to the center, but all are spread out. This is a high accuracy and high precision. So technically, accuracy and precision, right, are not defined for a single value. They're defined for a group set of values. You have to measure 10, 20 times, and then you can say something is precise or accurate. But then again, in 11th and 12th, we will not get into so much discussion. We'll keep it pretty simple, which is actually not right, but we'll keep it simple. Because exam like, this MIT, Manipal, Vellore, or even BITS, they don't get into that much. So example, let's say, the actual value is 4.423. And let's say someone gives you 2.413. Now, if you look at this value here, this is precise. So basically, we will say based on the number of digits, but less accurate. The value is 4 and you're getting 2. So but it has the same number of decimals. So the precision is the same. Up to the 4th decimal, you're able to calculate. Suppose if you have something like 4.413, this thing is precise. You have more decimals, meaning you're measuring up to that last thing, last decimal, and accurate. If you have something like 2.0, this is not precise, less accurate, and less precise. The value is also pretty far, and if you see there's only one decimal, meaning you're not measuring with a very good instrument. So you can say precision, at least for 11th and 12th, you can say precision is how many decimals you have, meaning up to what decimal you're measuring the value. So this thing, if you see 4.4, this is less precise but more accurate. You're at least closer to this thing. So it is always comparison with some other value. You can't directly say this is precise and this is this thing. You need a bunch of readings and then only you can compare. So just have an idea about this. We really don't have much on this, but in exams now, some exams they do ask which of the following is more precise value. He's indirectly talking about more decimals, which by the way is not the right definition, but it works. 11th and 12th, it works. But I hope you got an idea between precision and accuracy. Normally day-to-day life now, we use both the words like, it's a very precise value, say. It is not actually right. They don't mean the same thing. Precision and accuracy are completely different meanings. Clear? Now, whenever you report a value, how do you report? Now, the problem here is when you measure something, the instruments have a certain limit. You can't get perfect values there. So this is how you normally report anything. Let's say someone asks you to find length. We say length L is equal to L plus or minus delta L. So this delta L is your error. Example, let's say length is 10.0 centimeter plus or minus 0.1 centimeter. What this thing means is the measurement which you have taken, length can be anywhere. Length can be between 9.9 centimeter to 10.1 centimeter, meaning this thing has a precision of 0.1 on either side. Getting it? So reporting, so whenever you write answers, right, or when you do measurements, this is how you report. You just don't say 10 centimeters. In a scientific thing, right, this is very important. This tells you what kind of instruments you're using, up to how much error is acceptable. For example, like I told you last time, if a carpenter comes and if I have to tell him to design a door for the house, generally we don't need to tell him, but even they have a measurement. We tell them something like this, 2-meter height, right, plus or minus 1 centimeter. Let's say 1 meter wide plus or minus 1 centimeter, meaning the carpenter knows door का length 1 centimeter 2 meter से थोड़ा ज्यादा भी हो गया कम भी हो गया तो चलता है. That much error is acceptable for the client. But let's say if you're designing a submarine door and when you have to send the specification, same thing. You tell them, let's say 2.00 meters, let's say 0 meters plus or minus 0.001 meter. You send this precise. So the person who's designing the door, he knows, boss, this door is used for something special. It's like an airtight container. You can't have a gap more than this. Then I know what kind of instrument I have to use to design this. You're designing a door for a space shuttle, it will be something even more weird. 2.000 plus or minus you'll have 0.000. You don't want even a single air molecule to escape, something of that sort. So that error tells you up to what range you're okay to accept the error. Basically, the thing is nothing is perfect. So there is how much are you ready to accept? That is the thing there. So this is something I keep telling your seniors, don't worry about, completion of full portion. Sab log kaise hai na, sir, itna chapters bach gaya, wo bach gaya. Right now, you're 12th mein, that is the thing with most of your seniors. They're panicking. Normally happens because there's a lot. I tell them that only, boss, no one is asking you to score 100 out of 100 in advance. If you score even 60%, you're going to put a pretty good rank. You'll be in IIT Bombay. 60 to 65%. So the thing is, are you completing at least 80%? Think about that. Happened last week, I guess. One of your senior came and is like, "Sir, there is an exam coming up and there are 10 chapters. I don't know what to do. I'm getting tensed." A common thing that this thing happens every month. Someone says the same thing to me. I simply asked him, I think I told you this thing. I simply told him, like, in next 1 week, how many chapters can you do properly? He said, "Sir, I can do 4 to 5." I said, "Do those 4 to 5 properly." Sir, but what about the other 5 chapters? Okay. So do you have time to do everything? He said, "No, sir." Then do 4 to 5 properly. You're getting it. He knows in the mind, that he can't do everything. He had to do only 4 chapters properly, but somewhere his heart is not ready to accept, like, sab karna hai. So what most people do, right? After telling that much, they won't listen. They will try to do everything. End of the week, they'll mess up all the 10 chapters and come. So first of all, it didn't help you for the exam. Second, you didn't learn anything. At least if you have done the 4 chapters properly, next exam, when there are 14 chapters, these 4 are already taken care of. You could have done another 4. Next exam, when there are 20 chapters, already 8 chapters are done. You could have taken another 4. Eventually, the number of chapters will stop at 24 or 25. That is how you become strong in a longer run. नहीं हमको ये Sunday का marks चाहिए. That's the problem. No one wants to think about little long term. So if you have a measurement like this, p plus or minus delta p, we define something called fractional error. Which is the error by p. Then we define something called percentage error. We'll simply write like percent p, which is delta p by p into 100. Example, if someone gives you length is 20.0 centimeter plus or minus 0.2 centimeter. The percent error in L is 0.2 by 20 into 100. That's 1%. So you can also report this answer as 20.0 centimeters plus or minus 1%. Then it is understood. In this thing, there is an error of 1% in this reading. So when you find a measurement, how do you actually get the length? Have a look at this picture. All clear so far? Vignajit, Surya, Jainil, Arnav, clear? Now, let's say someone gives you a rod or something. Yeah, same thing. The percent error is fractional error into 100. Someone asks you to measure a length of a rod or a time period of something. How do you measure? You just can't take the scale and measure once and say, "Ye length hai." That would be wrong. So let's say you're doing an experiment to measure length. So listen carefully. I'll show you one and I'll ask you one more like this. So you take that instrument, let's say 1A caliper, screw gauge, or a scale or meter tape, anything, and you measure. Let's say you get the readings like this: L1, 10.2 centimeter, L2, 10.1 centimeter, L3, 17 centimeter, L4, 9.8 centimeter, L5, 9.9 centimeter, L6, 10 centimeter. You took a scale and started measuring, and this is what you saw. The first thing, this measurement is completely the odd one out. Getting it? So when you're measuring something, what happens, right? Maybe during this measurement, you're sleeping, or maybe you're looking somewhere else. Your friend came and knocked you out. कुछ तो हुआ है. मतलब, definitely this thing looks very weird there. Getting it? So when you do measurements, so this is the advantage I'm saying. Imagine you do only 2 measurements and you get 10.2 and 17. Now, aren't you confused which one is wrong? If I do 3 measurements, isn't there still a small chance that you did the mistake 2 times? But what if I do 6 times and now you tell me what is the chance that all these 5 are wrong and this is right? The probability drops. So these kind of, crazy errors, right? The crazy measurements will happen sometimes because of maybe you're not being more attentive or you did some kind of nonsense. So these kind of things, we can ignore this. So that is one of the reasons why you need to take a lot of measurements. since remaining values are bunching up close to 10 and this thing is pretty far, something must have happened. So we can be sure this reading is not done properly. So first thing what we do, we ignore that. Then we measure average value. So here average value is L1, L2, L3 is removed, L4, L5, L6 by 5. When you add all of these things, I give proper numbers. You'll get 10.0 centimeters. So we assume the average value is the right value. We treat average value as the actual value. And now you want to find the error delta L. Error is nothing but the actual value, that is the L average, minus the measurement. So then we find the error in each. So in the first one, the error delta L1 is the actual value is how much? 10. So 10 minus 10.2, that is 0.2 centimeter minus. The error in delta L2 is minus 0.1 centimeter. Error in L4 is plus 0.2. L5 is plus 0.1. Error in L6 is 0. So these are the errors. Now we never add the errors directly. We always have to take the maximum worst case. So we take all errors are additive. Later on, you'll see the reason why you should always add the errors. So we take the absolute error. That is, we take only the magnitudes. We don't take the negative values. So this guy would be mod minus 2, mod minus 0.1, 0.2, 0.1, 0 by 5. This turns out to be 0.6 centimeter by 5. Remember, this is a number. It has infinite SF, and this guy has only 1 SF. This turns out to be 0.12. Since it's 1 SF, we round off this to 0.1 centimeter. So this is how you report the final answer. So after taking the scale and measuring it, you report the length is 10 centimeter, the average. Plus or minus, this thing has an error of 0.1 centimeter. The percent error in length is 0.1 by 10 into 100. That would be 1%. So when you do an experiment, this is how you actually do the measurements. First, to take some 10, 15 readings, right? Eliminate any row values like this. Then just add all of them, get the average. Assume this is the actual value. But here, actual value, there is an error. So we find the error in each reading. Then we add all the errors, positive. Then we report the answer like this. This is the process of when you measure something. At home, though, we just take the tape and measure it once and finish it off. But in a scientific measurement, this is what you do. And this is the reason, certain experiments, right? They take a lot of time. Let's say there's an experiment with a high chance of getting an error. Then they repeat the experiment like 10, 20,000 times. Now, repeating an experiment 10, 20,000 becomes very difficult in real life. So we use computer simulations. So you can run a simulation in a computer maybe like 1 lakh times. Previous slide is this. So do have a look at this, how we did this once. Let me give you one more like this. You guys can try. Clear? Let's say we want to find time.
Please wait for a second.
All right,
Yes, thank you, sir.
go ahead. Consider a measurement of time. They do ask questions like this. In a simple pendulum. So you are trying to find the time period of a simple pendulum. So these are the readings. T1, 5.10 second. T2, 5.20 seconds. T3, 4.95 seconds. T4, 4.80 seconds. T5, 4.90 seconds. T6, 5.05 seconds. T7, 8.25 seconds. So find time. They'll simply say like this, find time. Matlab, they're expecting you to tell me time plus or minus error. Or you can simply say percent error in time. Let's get this, everyone. Try. I'll give you a minute or two. Just give it a try. I'll be back in a minute. Any answers? 5 plus or minus 2%. अरे you can't give 3 decimals रे God, यहाँ पे सिर्फ 2 decimals है. Let's see. First thing, ignore this guy. That guy completely is out of sync, so we'll ignore that. That is 8 almost, and then find average. So T average, I gave proper values. It will come out to be 5.00 seconds, right? And then let's find the error in each. Remember, error is T average minus the T. So here we have minus 0.10, minus 0.20, plus 0.05, plus 0.20, plus 0.10, minus 0.05. And then we take absolute error. Absolute error may always add them. So minus mod 0.10, minus 0.20, 0.05, 0.20 by 6. How much is this? 0.35, 0.35, 0.7 by 6. 0.706 is 0.1. 10 to 0 to 407. But you can clearly see here there are 2 SF. And this is a number. So we round off. So 7 is greater than 5. We round off this to 0.12. Therefore, your final answer time is 5.00 plus or minus 0.12 seconds. You want the percent error in time, that is 0.12 by 5 into 100. That is 20, that is 2.4%. Is this clear, everyone? Easy, but this is what I was saying. You should be doing like this. So if you want to even find time, you just don't measure it once. So the whole idea of taking readings is, when you take large enough readings, the positives and the negatives, right, you will end up with a decent thing. The errors will start reducing. It's like, imagine you went out to do a survey and you want to find what is the average salary of a person in Mumbai. Unfortunately, the first person you interviewed is Ambani. So what happens? The whole reading gets messed up, isn't it? Now that one guy gives you such a hopeless reading, your entire survey goes to for a toss. Now let's measure second thing. You go to a beggar. He says 0. Your average is still something like what? 200, 300 crores per month. I think that one Ambani is earning, let's say, 200 CR per month. Meaning that is still assuming that is what he gets. And it's still 100 CR. Now we take third beggar. It is still something. Now to just average that guy out, you need at least something like 1,000, 2,000 beggars. So he is an anomaly there. Now, and even beggar is an anomaly. So let's say if you take actual reading from 10,000 people, and in that you find out 10,000 where there are 4 people earning more than 100 crores. And then 10,000 where 1,000 people are beggars. And remaining 9,000 people are giving values of 1 lakh, 1 lakh, 1.2 lakh, 2 lakh, 3 lakh per month. Now, this is the data which you want. So you will remove everyone who is below 10,000 and you remove everyone who is more than 1 crore or maybe 50 lakhs. And you'll take the set of values between 50,000 to 5 lakhs maybe. Getting it? And then you will try to get their average. So that makes more sense. So these anomalies are always there. You remove them. And maybe you're doing this survey, right? For let's say you're trying to sell let's say you're working for a government project where you're trying to build apartments for, let's say each one will cost around, let's say 70, 80 lakhs. A person who is earning 50, 60,000, maybe it is for them. So why do you want to take a survey for a person who is earning 1 crore per year? That guy will never stay in your apartment anyway, which you are building for 50 lakhs. So the data matters. Like, what is your data set? So without knowing that, you just go into the market and doing random survey, it is useless. This thing helps a lot in marketing. This is what people do actually. They know, like, we are trying to, let's say, ever seen this thing? Best example is this. You go and try to buy biscuits. Go to a shop and try to see biscuits. Biscuits, may you'll find three types of biscuits. There's a low category biscuits like Parle G, Britannia Tiger, which you'll get for 10 rupees, 5 rupees, 6 rupees packets. And there's a middle class biscuits, the middle thing, like, the Parle, this thing, Marigold, getting it, Marigold or Crackjack and something like that. And then you go on the little higher end, then you'll get this, the Sunfeast ka cream biscuits, Jim Jam. Getting it? Even if you go this little higher end, then you'll get this, ITC ka, you get that thing, you have a full chocolate filled and everything. You break that, the chocolate literally flows out. So there are different segments. And if you see this thing, right, the same company makes all the four biscuits. And there are certain companies, right, they don't want to. And so this is an example of ITC, a dark fantasy. So ITC, right, initially, if you say ITC was a cigarette company, then they realized they're not able to make more profits on cigarettes. Matlab, there's a limit. Then they said, yeah, now let's do something. Let's do some other business. What else can we do? They started selling atta, Pillsbury, that thing. If you see, right, if you go and see ITC ka atta, the wheat, the thing which they sell is one of the largest. And they said, let's get into biscuits also. Now, when they entered into the biscuits, they had a big problem. Good Day was dominating, right? The Good Day was also comes in this, high segment here. Then the lower segment, mein Parle G and Britannia Tiger are dominating. Crackjack and all are dominating in the middle. Marigold. So these people didn't understand that where can we compete? There's already a big market there. It's difficult to enter. Then they realized there are few category of the people, right, who are okay with the price. They just want something like super taste. Meaning you put the price 200 rupees for biscuit packet and people will still buy. But you need to give them something really premium. And how will you know this thing? You go to a supermarket and you see how many people are buying high-end biscuits, this biscuits and this biscuits. You need not even go and see. Every day at the end of the, after 1 month, go and collect the data, which biscuit company sold how many biscuit packets. And from there, you'll realize, let's say here, if 1,000 people are buying from DMart this biscuits, and there are 400 people buying from DMart here, and there are 200 people buying here. Now that means in that 200, there'll be at least 50 people who are ready to buy even higher end. So that is my market. I don't want to fight with these people and this people and these people. I will, just think about it. Dark fantasy and Parle G biscuits. Is there any comparison? You will never even think about comparing them, isn't it? Dark fantasy and Marigold. You'll never think about, comparison. Thought ही नहीं आता है. So data matters a lot. What do you guys think? Apne Instagram, Facebook, all is there. Free of cost, right? How do you think they make profits? Your data. Best thing मैं बोल रहा हूँ ना, आज after the class gets over, go to Amazon, just hit diapers. Just search diapers and close it off. Tomorrow say you'll get diaper ads. The worst part, same Wi-Fi, your mom is searching for diapers, you start getting ads. That's the thing. So when something is free, remember you are the product. Let's see you next time. Now these errors are of two types. You guys never thought about, no? ये सब थोड़ा high है. You should go to a DMart. You should go to any, shopping mall or marketing thing, this DMart or something. You will literally see marketing tactics. Think about it. The door you enter and the door you exit are two different. The entry and the exit, it is not easy to directly go from entry to exit. You have to go through a maze. The moment you enter, they'll give you an empty basket. Kabhi dekha? They'll put a basket in your hand. Now, you will take the basket because he gave you. You just came to buy one Dove soap. First of all, finding the Dove soap, you will go mad. Don't know where it is, you'll keep searching. Now, in this process, you will be carrying an empty basket everywhere. Now, you'll become conscious. अरे यार basket में एक भी नहीं है. Everyone is looking at me. Observe that. And then when you enter, first thing you'll enter all junk food ka section. Biscuits, cream biscuits, big offers, 50% off, that off, this off, chocolate, bullshit, everything. You will still resist and say, yaar, mujhe chocolate nahi khana hai, let it be. You will keep on searching. You will find this rice, dal, all these oils which are essentials will be somewhere in corner hidden. That is what people actually come to buy in bulk, but hide it somewhere because anyway you are going to buy that. But before that, mesmerize you by showing all nonsense stuff which you won't buy normally. And make sure to stamp on everything 30% off, 40% off, buy two, get one free. So they will blast. So you have to have a lot of self-control. Chalo, फिर भी तो self-control कर लिया, you went there. Once you went to the rack, that Dove soap के side में there are multiple options. वो छोड़ दो, same Dove soap. If you buy one Dove soap, 30 rupees. If you buy two, it is 55 rupees. If you buy full pack of 12, you will get it only for 100 rupees. बड़ा discount दिखेगा मतलब. Then the one who came to buy one, he will suddenly take a pack of 6 because discount में मिल रहा था. इतना हो गया, right? चलो, and then finally you say, let's get out of the exit. And imagine you take a kid with you. Ever seen that cash counter पास क्या होता है? All that, chocolates, that small toys. वो क्या था? Kinder Joy, egg. All this bullshit they keep near that cash counter. So while going, this kid won't keep quiet. Oh, मुझे Kinder Joy चाहिए, मुझे वो चाहिए, ये चाहिए. That guy will just jump on the chocolates and will put them in the basket. And this is the best tactic, huh? You will shout on the kid and say no chocolates, and the kid will literally start crying there and make a scene in front of everyone at the cash counter, and everyone is looking at you. Now you have two options: slap the kid, drag him out, but you will become the villain in front of everyone. Or just सोचो यार चल छोड़ दो करके, you put that in the basket, you accept it, and you get out from there. चुपचाप you'll just put in the basket, you'll accept it as a fate, and then you'll get out from here. That entire thing is designed to make sure once you get inside, you buy something and go. And if you go with an empty hand, they will make you feel like, yeah, you are doing a big cheating to us. That's how it works. You guys never observed, na? Next time when you go observe all this thing. It is one of my favorite activity. When I am totally free, kuch kaam nahi hai na, I just go to DMart and I keep roaming around. Nothing. I don't buy single thing. I just keep roaming around. I keep sitting there and I keep watching people. Especially allowed to sit near that, cash counter and look at the kids. यार इतना ड्रामा करते हैं ना, they do any nonsense. The kid and the parents are fighting literally. Kid wins all the times. And the guy who kept that shelf, they know. And observe that thing, all the chocolates are at the height of where kids can take it. They'll never keep the chocolates at a higher distance. They'll always keep it that way. And they'll always make sure, even if there are 10 cash counters, they open only 4. Because you want the crowd to be there and you want to give them more time to pick up things. It's a game, right? So what do you guys are thinking? You're thinking you're learning maths, physics, chemistry. Bullshit. You're learning how to analyze situations through maths, physics, chemistry. So use all this. Once you go out, this is what you should be learning. Technically, school mein, you should have a courses and all this stuff. Instead of teaching all this stuff, we teach all shit. Anyways. Random errors. So these things, right, they happen due to external conditions. Maybe the operator, let's say you and I are measuring with the same scale, same instrument, everything same. You tell me, sir, it is 5.35. I say, nay, it is 5.36. Maybe our visions are not right. Maybe my vision is bad. So I'm seeing something little more or little less. So the same instrument, same device, but two different people will still give you different answers. Variability, even you, the same person, right? You measure it 10 times, you'll tell 10 different readings. Maybe the measuring device is messed up. Let's say if you use two different skills, they might get different values. So all these things, right? Technically, random errors are not in your control. You can't do much about them. So the only way you can reduce them is by taking a lot of measurements. Instead of 10, take 100, the error will decrease by 1/10. These can be decreased by taking a lot of measurements. And then taking average value of it. There's a second type of errors called systematic errors. These errors, right, can be, this happens due to you're not careful. Maybe you're not being more attentive, or maybe you used a very bad instrument, like that scale which I said, you ate the scale, bit of it. So these things are something which you can control. Be more careful and use proper instruments, and these things can be eliminated. So it happens due to error in procedure. Maybe the whole procedure you started is only wrong, or error in instruments. This can be eliminated by being more careful. Right. So whenever you get 2, 3 measurements, so how do you add them or how to subtract them? So this is again one more thing. So when you're adding errors, you have to be careful. So listen to this carefully. Addition and subtraction of errors. Now you will understand why I'm saying, errors should be always added up. This will give you the reason. Let's take a simple thing. You have 2 rods with you. First thing, let me add up. The errors always add up. So let's say you have 2 rods, 10 plus or minus 0.1 centimeter. B is 5 plus or minus 0.1 centimeter. The meaning of this is this length can be anywhere between 10.1 to 9.9. This B can be anywhere between 5.1 to 4.9. So you're trying to construct 2 rods, length L, and another rod, B. We are trying to join 2 rods. Now, look at the worst thing that can happen. We will take the cases with the maximum error. So in science, right, the thing is this, we always take the worst possible situation and we want to be prepared for it. So when you add L plus B, what is the worst thing can happen in one way? The worst thing can happen is you took both of them on a positive side. Means you took 10.1 here and 5.1 here. Then your maximum error will come as 15 plus 0.2. What is the other worst thing that you can do? Take both of them less, 9.9 and 4.9. In this case, you can get 15 minus 0.2. That means when you add these two values, your value can lie anywhere between 15 plus or minus 0.2. Is that making sense? I wrote 2 times. Where did I do that? 0.1. What did I write 2 times?
In the last
Dude.
page.
Okay. ठीक है ना, वो डाउट है यार, कुछ अच्छा पूछो ना. Out of all the things you can ask, that is the thing you had. ठीक है. Next thing, what if you subtract them? Now, what is the worst thing you can do while subtracting? Take L ka maximum, that is 10 plus 0.1, and take B ka minimum, B ka the other worst one, 5 minus 0.1. You end up with 5 plus 0.2. What is the other worst thing you can do? Take L ka minimum, 10 minus 0.1, and take 5 ka maximum. So this can end up with 5 minus 0.2. Means here also you can see the L minus B ka value will lie between 5 plus or minus 0.2. This is what I was saying. Whether you add or subtract, error always adds up. Is this making sense? So whenever you add two values L plus B, directly add them. Errors also will add up. It doesn't matter even if you subtract them. If you subtract them, this is the scenario. The worst case is that. Clear? Let's see a question how they'll frame on this. But is this clear, everyone? Why you should always add the errors? Let's see a question. Let's say we have a resistor R1, the resistor R2, both are in series. We get R equivalent. Let's say R1 is 20.0 plus or minus 0.3 ohms. R2 is 10.0 plus or minus 0.1 ohms. Find R equivalent. This is easy. So just add it up. So R equivalent is R1 plus R2. So that will be directly 30.0 plus or minus 0.4 ohms. If they ask you for percent error, I didn't ask you, but if I'd asked you 0.4 by 30 into 100, that would have been 40 by 30, 4 by 3. That's 1.3%. Clear? Next one. So this is a rectangle, length L and breadth B. Find the error in perimeter. Addition subtraction is easy. So perimeter is simply 2 times L plus B. So L plus B is simply 15 plus or minus 0.3. That is simply 30 plus or minus 0.6 centimeters. Just multiply, done. You want error in P, that would be 0.6 by 30 into 100. That's 2%. Clear? The next one. So this is addition subtraction. Clear, na, Arnav? Arya? Easy. Next thing, power rule. This takes care of multiplication, division, and stuff. So let's say we have a quantity A is equal to P power X, Q power Y, and R power Z. It is depending on different quantities like this. Then this is what we do. Put ln on both sides, logarithm. Then this will be ln A. Then you know what happens to this thing, ln Px, ln Q power Y, minus ln R power Z, or minus Z. Then differentiate on both sides. This ends up at dA by A. This becomes x dp by P. This becomes y dq by Q, minus z d is R by R. Now, errors are always additive. So we ignore the minus sign, we just put a mod. So dA by A, the error in A by A is given by x times dP by P, put a modulus, plus y dq by Q, modulus, plus z dr by R. So just put a modulus. This is the formula for errors. But there is a catch with this. This guy is useful only when the error is small. Preferably 5%. But technically, the smaller the better. Why so? Think about it. The moment you say dA, dP, aren't you talking about a very small change in values? 10% is not a small change, right? Technically speaking, dA, dP should be something like 0.1, 0.01. We are talking about such small values. But up to 5% is still acceptable. So keep that in mind. Example, they'll give you a question like this thing. Let's say A is equal to P square, Q3, R power 4. Let's say percent error in P, Q, and R are 1%, 0.5%, and 0.2%. Then percent error in A, so you can just multiply 100. You'll get 2 times percent error in P plus 3 times percent error in Q plus 4 times percent error in R. You can just directly add it up. So 2, 1.5, and 0.8. 3.5 plus 0.8, 4.3%. Make sense? All got this? Great. Let's see a question on this. 10.0 centimeter plus or minus 0.2, 5.0 centimeter plus or minus 0.2. So this is the length and this is the breadth. So find percent error in area. Find percent error in area, both the things. This is a good one. First one is the standard question. Second one actually tests like what did you understand. Get them both. Hmm. 0.8. First one is easy. Hmm. See the first one. So first one, we know area A is L into B. So basically this is L power 1, B power 1. So dA by A is dL by L plus dB by B. So dL is 0.2 by 10 plus 0.2 by 5. That's 0.6 by 10 dA by A. So if you just want the error, the percent error in A would be 0.6 by 10 into 100. That is 6%. If you want to find the area, first of all, area is L into B is 50 centimeters. So dA will be 0.6 by 10 into area. So that is 0.6 by 10 into 50. That is 3 centimeters square. So you should report your final answer like this. 50 plus or minus 3 centimeters square. Clear this? So if they ask you find area, this is how you'll report 50.0 plus or minus 3. But if you want percent and error, 6%. Just to give a little context here, if you think about it, this thing is roughly around 2% error. This thing is roughly around 4% error. Yeah. So it is still acceptable range. But look at the other guy. This thing has deadly errors. This is 10.0 plus or minus 2 centimeters. 5.0 plus or minus 2 centimeters. This thing you have 20% error and this thing has 40% error. Power rule will go wrong. That's the first thing that should hit you when you see such a big number. But chalo, फिर भी use करके देखते हैं, what will you get? So if I use the formula there, dA by A, so I'm using A is equal to LB, dL by L plus dB by B. You end up with 2 by 10 plus 2 by 5. That is 6 by 10, and percent error in A would be around 60%. Okay, that's a big error. But let's say actually how to find. This is wrong. This is how we do actually. So think about the worst thing that can happen. What is the worst thing that can happen? The maximum area or the max worst thing that can happen. Max area possible is nothing but when L is 12, the upper limit, and B is also the upper limit, 12 into 7, 84 centimeters square. Make sense? So the max error possible would be max area possible minus L into B, the regular value. The max area is 84.0 centimeter square and the regular area is 50.0 centimeter square. Means you can get an error of 24 centimeter square ka error. So percent error would be 24 by 50 into 100. 34 na? 34,000. 34 into this turns out to be, how much is this? 68%. So that's the answer. So in the exam you have 60 and 68. 68 is the answer. Getting the catch? This is still dicey. Huh? Generally they shouldn't touch this thing, but it is still dicey. Matlab, I won't say this is perfectly right, but this is definitely wrong. That much we know. All clear with this? Next one. All clear? Turning the page. Now, sometimes in the question that they won't give you the error, but there is an error. A cylinder of radius r 10.0 centimeter, height 20.0 centimeter, it's a length. And mass 40.0 kgs. They give you something like this. Find error in density. Now, whenever they give you values like this, understand. So when they said R is 10.0 centimeter, you're saying I'm using a scale up to 1 decimal. So this implies 10.0 plus or minus 0.1 centimeter. Understood? If nothing is mentioned, this is how you take errors from the decimal. Either you have to give me the errors. If you don't mention, I'll assume this way. You said L is 20.0 centimeter. This means 20.0 plus or minus 0.1 centimeter. That is how values are taken. Same thing when you say mass is 40.0 kgs. So up to 1 decimal. If I had taken 40.00, I would have taken 0.01. That's the meaning of this. So based on the number of decimals, you can figure out the error also. Get this, find the percent error in density. See. Now, when you take a cylinder, length L, radius R, what is the volume? Pi R square L. So what is density? Rho is mass by pi R square L. So d rho by rho, dm by m, d pi by pi, but that will be 0 because it's a constant. So you can actually ignore any constants that are there. 2 dr by r plus dl by L. Then what is dm here? 0.1 by 40, 2 times 0.1 by 10 plus 0.1 by 20. You want error, just multiply into 100. To multiply into 100, you get 1 by 4 plus 2 plus 5. That's quite big. 0.5. Yeah, that is 0.25. So that's 2.75%. Got this? Easy? Any doubts on this? Next thing. Next thing. We know kinetic energy, I'll call it K, is half mv square multiplying divided by mass. This guy becomes mv whole square by 2m. And m into v is nothing but momentum. So the relation between kinetic energy and momentum is p square by 2m. M is the mass. Okay? Now look at the question. Find percent error in K when the percent error in P is first one 1%, 10%, 100%. So when the error in P is 1%, 10%, 100%, find the error in K. If I ask you this question, I'll ask you the B part in the exam. This is the kind of questions you can expect. Try, it's a good one. So that is the formula I gave you. K is P square by 2m. So find the error in kinetic energy when the error in momentum is 1%, 10%, and 100%. Try. It's a good one. You try to one thing. First use power rule and see, and then see what does it make. Think I'll give 2-3 minutes and I'll show you.
Will we assume mass is constant?
Hmm. First, let's use power rule and see what you get. So K is equal to P square by 2M. So dk by K is 2 times dP by P plus dm by M. But this is 0 since M is constant. So we get 2 dP by P. So literally percent error in K is 2 times percent error in P. So for the first case, the answer would be 2%. Second case, the answer is 20%. The third case, the answer is 200%. Mass constant there, na? I didn't give you. Right, mass is constant. Now, look at the actual thing, actually. So in the first case, when you say the percent error in P is 1%, means you're saying the pK value, what is the maximum possible value of P? For simplicity, I'll just call this PF, okay? Which is 1.01 P. Agreed? Isn't that the meaning of 1%? You have 100 rupees, you have 1% more. Matlab what? You have 1 rupee more, isn't it? So what is your final value? 1.01. Is that making sense? So now, using this, if you find the final kinetic energy, we have to do P final square by 2M. This turns out to be 1.01 ka square, P square by 2M. So this is 1.0201 K. So the change in kinetic energy would be K final minus K. This turns out to be 0.0201 K. The percent error in K is nothing but delta K by K into 100. When you do this, you get 2.01%. So the actual answer is 2.01%, but this is acceptable. Matlab, fine, there's an error in the second decimal. That's what I said. When the error is very small, you get a pretty neat answer. But look at the second guy. When you say percent error in P is 10%, that means you're saying P final. Think like you have 100 rupees, you have 10% more. Means what? You have 1.1 P, right? Make sense? So what is kinetic energy final? 1.1 square P square by 2M or 1.21 K. So delta K would be 0.21 K. So we get percent error in K would be delta K by K into 100. That's 21%. This is wrong actually. The answer is 21%. Exam they'll ask you this, and both the options will be there, 20 and 21. Everyone will mark 20 and come. I'll turn the page. Look at the third one also. When you say percent error in P is 100%, think about it. You have 100 rupees, you have 100% more. Matlab, you have another 100 rupees, right? It doubled basically. So P final became 2P. So kinetic energy final is 2 square P square by 2M. This is 4K. So change in kinetic is 3K. Therefore, percent error in K would be delta K by K into 100. 300%. Did you see? This is what I was saying. As the error becomes bigger, your power rule will start giving very wrong answers. The power rule is not accurate. Power rule, we are using differentiation. The moment you use differentiation, you're talking for very small quantities. The error should be very small. So for 1%, you are getting an error of 0.01 ka difference. So that is okay. But when you went to 10%, suddenly you got 1 ka error. 100% you got pretty big error. Is this clear, everyone? Any doubts on this? Clear? Next one. In a simple pendulum, a stopwatch a least count of 1 second is used. Least count, the smallest measurement you can make. Basically, that will be the error. For example, if you take your scale that you use at the school, that is the smallest error is 1 millimeter. Smallest measurement. Or the smallest value that can be measured. This can be taken as error. So this thing, it measures 200 seconds for 100 oscillations. So when this pendulum is oscillating, the length of the pendulum is given 1 meter plus or minus 0.01 meter. This is the time period का formula. Two pi root over L by G. Find the percent error in gravity. So using this experiment, you can find the gravity axial. This is an important model. Now, one thing I'll tell you, whenever they ask you something like this, T is equal to 2 pi root over L by G, you get T square is 4 pi L by G. Bring G to this side first of all. 4 pi L by T square. So dg by G is equal to dL by L plus 2 times dt by T. That's a catch. L is given
No.
R.
So it should be 4 pi square, right?
ठीक है, वो doesn't matter anyway, luckily. But 4 pi square. Now, what is the error in this thing? So here, this is the thing. So the stopwatch measures 200 seconds with an error of 1 second. That's the meaning of least count. Matlab, when you say 200, it could have been 199 or it could have been 201. You're not sure. So there's a 1% error. One error. with an error of 1 second. So that is the thing. Indirectly, he gave you that way. So we can say delta t by t is 1 by 200. And then you are done. You can just directly substitute it. So this guy is 0.01 by 1 plus this is 1 by 200. 1 percentage error 0.02, 2%. So that is the thing. So the idea here is, see, the idea is this. Let's say if you do only 10 oscillations, you will get 10 seconds, but error is 1 second. So 1 by 10 is a big error. If you take 100 oscillations, 100 seconds, error is still 1 second. Matlab, no matter how much ever you measure, error is always 1 second only, right? So by taking a lot of oscillations, you're decreasing the error. That is the reason when you do a simple pendulum experiment, you just don't measure for one oscillation. Matlab, simple logic socho. If you just do one oscillation, you'll get 1 second. Error is plus or minus 1 second, isn't it? But when you do 1,000 oscillations, the error is spread over 1,000 oscillations. So in an experiment, that's why you take more oscillations, more readings and more oscillations you take, your error spreads out. All clear with this? They're almost done with this. There is 1 or 2 more models. So next class, we will do them. I think another 15, 20 minutes, we'll wrap it up. So there are 1 or 2 good models there, which the power rule doesn't work and the addition subtraction doesn't work. So there is something like that, which I'll teach you in the next class. We'll finish out that another 15, 20 minutes in the next class, and then we'll start off with Newton's laws of motion. So the chapter as such, it is almost done. You can start solving on this, whatever material you're having. Plus, I'll send you sheets today on units and dimensions and errors. So finish off that much, it is taken care of. Okay, so with that, we'll wrap up for the day. We will discuss the paper ka doubts, the kinematics ka thing. So first, any doubts in today's class, you can ask me. Okay, let's see the paper ka doubts. So if you have no doubts, you're free to leave. Those are doubts to stay back. So let's go in an order. I hope everyone has solved the paper. It's a pretty good paper.